Welcome to today's workshop. We titled this Building Near Real-Time Data Products with SQL. And I think this is a very important topic for engineers because we're not just doing the engineering for engineering's sakes, but we actually want to build data products. And for this, I have invited two guests here today. I have Roy Hassan here, who is the head of product at Upsolver, and I have Jason Hall, who is the senior solutions architect for Upsolver, and they're going to tell us more. We're going to learn how to actually create a data product. So let me bring them in. Hey guys.
Hello.
Hey, Anders, how are you? How's everybody doing?
Welcome. Yeah, how's everybody doing? Put a hello world in the chat. I already see a few people. Kate is here. Hi, Kate.
Oh, very nice. Hey, Kate, how are you?
We were actually talking before our stream here. Matthew is here. Hi, Matthew. And Salman, just a few. Yeah, if you have questions, what we're talking about, put them in the chat. We're going to take the questions if they fit immediately, or we're going to address them in our Q&A section. So, yeah, guys, maybe you say a few words about yourself so people can actually.
Yeah, sure. So maybe I'll get started. So my name is Roy Hassan. I'm the head of product at Upsolver. Previously with AWS, I worked on many of your popular services like Amazon Athena and EMR and AWS Glue and a few others. So really excited to kind of talk about what does data product actually mean? How do we see it with Upsolver? How do we see customers in companies in the industry building these data products, becoming more self-sufficient? So we'll talk about a bunch of different topics today. And then at the end, we have a nice, that's kind of hands-on hands-on workshop that we will go through. We will actually do the hands-on for you. But if you choose to do it on your own, you can actually log into the Upsolver product. And we have a template, we have a worksheet there that has all the commands in it, and you can just execute it on your own. So fun times, looking forward to it. Questions, interact, ask questions as much as you want, but that's pretty much it. Jason?
Thanks, Roy.
Sure. Yeah, so my name's Jason Hall with Upsolver. I am a career-long data professional. Most of my career was in more traditional database administration work, and fairly recently I've come over to the data engineering side. So I think much like a lot of the audience and a lot of the folks working with data pipelines, I've spent a long time with data and are fairly new to data engineering. I'm a solutions architect with Upsolver, so my responsibility is mainly in assisting customers in evaluating and implementing the Upsolver data pipelining product. So spend a lot of time speccing out use cases, brainstorming ways to solve problems, and then ideally assisting customers carry out those use cases in the production pipelines. So I'll be lending my hand to Roy as we get into the workshop, and looking forward to the session today.
What? Yeah. All right. Yeah, thanks that you're here, guys. Because Kate is already asking here, what skills can we learn from today's workshop? I think let's go quickly over the agenda. So, and then maybe we can already bring or answer this question a bit. So first of all, we're going to look today into challenges to deliver reliable and accurate data. And then we're going to look into what is data product, because not everybody knows this. Options for engineers to build actual data products, and the benefits for the users of that data, of these products and the consumers. Then, as Roy said, we're going to do an extensive hands-on part here that you can replicate. We thought of doing this here like a painting by numbers, and then you do this on your own if you want. Roy has everything, and Jason, they have everything prepared. And then we add a Q&A at the end. So, yeah, maybe... Roy, do you want to add something about Kate's question here? About the skills?
Yeah, no, I think you touched about a lot of different stuff. I think the kind of the soft skills, if you may, or the knowledge skills would be around kind of understanding what data products are, when to use it, how to use it, kind of like how do you position it within your organization, right? You probably hear a lot about data mesh and data products, and like, so I'm trying to take those high level ideas and concepts and kind of bring them down to earth and talk about like, how do we actually implement them? How do we actually implement them in your organization so you can start seeing, the collaboration between data engineers and data consumers, like analysts, can materialize better in your company. So I think that's one aspect of it. The other aspect is Jason and I will kind of go through hands-on workshop with the Upsolver SQL Lake product. So you'll actually see us create using SQL data pipelines that both ingest, stage the data, and then transform and load and materialize that data in ways that make sense. So as you see in the workshop, we'll kind of break it up by a data engineer, the kind of the data producer aspect, and then the data consumer, like an analyst who's using that. So those will be kind of the technical skills that you learn in this workshop. And if there's anything else that you want to hear about and learn, definitely let us know.
Yeah, ask questions about this. I think for an entrance here into our event, we were talking about this before, Roy, and I asked this on LinkedIn. I asked today, how long does it take to get from raw data to business value, to a product, to actually generating value? And I gave the options hours, days, weeks, and months. And some people, actually 30%, roughly 31 said weeks, 35 said months, but there were also people that said hours and days. What are your thoughts on this?
Yeah, it's a good it was a pretty good and timely survey, because when we talk to our customers, actually, if you want to share the screen, I have a slide that I prepared to kind of talk about what we're seeing with our customers, right? So when we talk to people, well, whether it's our customers or potential customers, we typically hear that ingesting data, getting data into either a data warehouse or your data lake actually takes days. It's not a lot of effort to get data in, but where people spend a ton of time is in that preparation, transformation, optimization of the data, right? So like getting data in is fairly easy, but then weeks and months it takes to actually prepare the data and get it to a point where it's actually useful, right? We see, DBT and Airflow and Snowflake, and we see Databricks, and we see AWS Glue, like different ways to transform the data. But all that stuff takes time, right? I mean, you run a query, you write some code, then you realize what you have mistakes, you have errors. You first got to learn how to write the code, whether it's SQL or Python or Scala or whatever. Stack Overflow, we spend lots of time there just kind of figuring out how to get things working. And then you run it and you realize, okay, in your sample data, it works fine. But once you start adding more data to it and kind of opening the fire hose and moving the full data, you realize that, hey, it's actually not scaling. I spent a ton of time in my career at AWS, like working with customers to simply scale their jobs. I did a lot of this in Spark with Python and Scala, and like just writing the basic transformation was actually fairly simple. But once we threw more data at it, that's when things start to fall apart. And now you're into like, how do I optimize this stuff? How do I optimize my data? How do I optimize my code? What's the best way to kind of write your code in a way that doesn't break, right? So that's where you spend a ton of time, and you don't notice, but days go by, and then like you're into multiple weeks, and they're like, wait, I still don't have this data. It's really frustrating, and that's what we see. When I talk to customers, are saying, we spend time building data lakes, but we're not getting any value out of it. We're just kind of sitting here and just trying to scale this thing and trying to make it work. And these jobs getting stuck all the time and keep failing. Like, we're not getting any value. That's the problem, right? That's the issue that we see, is that this building these transformations and managing the data and scaling it is really hard. And you can say, well, let's just put it into Snowflake or put it into Redshift and it's just going to go away. But the problem doesn't really go away, right? You just put it into another system. You still got to run transformation. You still got to do it. And we hear a lot about, hey, Snowflake's very expensive because you're doing lots of unoptimized transformations inside of Snowflake. So maybe you're not having your jobs crash, but you're paying more for it. So anyway, the point is that it just takes a long time to get this work done.
Basically, this 90% here where you're working with the preparation. That's a big deal.
Yeah, it's finding that, it's first of all knowing how to write the transformation that you want to do, right? And that's okay, right? That's the business logic you're trying to figure out. But then you realize very quickly that it's not the most optimal way to do it, because as you put more data into it, it starts to get really, really slow, or your job crashes because it runs out of memory, and now you're dealing with all these extra things that nobody really wants to work with. And then on top of that, you got this orchestration thing. Like we talk a lot about Apache Airflow, right?
Yeah.
And building DAGs that orchestrate the systems. That's another thing that the users have to go learn, and it's all in Python. So you got to learn that, and you got to learn how Airflow works. And it's just, it's really a lot of work and a lot of trial and error until you get things done. That's why, we see data engineers primarily dealing with the ingestion, transformation, the loading of data, kind of like everything in your data pipeline. And there's a lot of trial and error that I have to go through and best practices. So how do we really get to a point where a data engineer can kind of do one part of it, and the data consumer, analyst, data scientist, business analyst can come in and kind of take over from what the data engineer did, and kind of do the things that they want to do without having to be dependent on somebody else. Yeah. And that's the friction, right? It's all the stuff that the user has to do. Like we can't go teach, business analysts how to do those things. It's not fair to them, right?
Yeah, it's basically the balance that is important, right? Yeah. You want to have not the data that the data engineer comes in, does the first part here, does the ingest part, and then leaves everything else on the analyst, like done.
That's right. That's right. Yeah, because we talk about like data analysts and and data engineers kind of talking to each other and figuring out like, hey, I ingested some data. How do you want this data to look? What should it be modeled at? Like, yes, we should have that dialogue, but what if we also get to a point where a data engineer kind of brings the data in a scalable way, right? So if the volume of data goes up, it's not going to fall over. But then the data analysts, maybe they don't necessarily have to have that conversation, right? They're like, okay, you brought me the data, let me model it. I know how it should look. Let me model it. It's not that hard to model it in the right way. And then we have a consistent kind of experience, consistent schema, consistent model of the data that other users can consume. So if you look at what data meshes talks about like these data domains. Each domain is responsible for their own data, right? So they're producers of their own data, maybe even consumers of their own data, but then they share the data with other domains, other groups in the company. Sounds great, but realistically, like how do you implement something like that, right? And that's kind of what we want to talk about today as well.
It's very difficult. So this is also something where you're coming in, like from Upsolver, because as you mentioned also in the beginning, then you have a lot of tools. You need to do the orchestration. You need to do, let's say you have Spark. You need to write Spark jobs for this. If you're an analyst, you can't do that, or you have a steep learning curve of actually getting to that point. And that's what I found so interesting when we first talked, Roy, that you said, okay, our job is to actually do this all with SQL and make this easy for people, right?
Yeah.
So can you tell me a bit more about this?
Yeah. So again, the whole idea of the whole idea within data mesh around these data domains and self-service analytics. So there's a lot of pieces to data mesh, but the piece that really resonates with me and kind of how we structured our product is making data more self-service for users, right? So we can always say, hey, just use Databricks, use Snowflake, but if you think about it, like if I use Snowflake, well, what does that mean, right? I somehow need to get data into it. So where do I bring data? Do I need Fivetran? And I need some Kafka data because some of it is streaming. Maybe I have some data on S3 that I'm getting from a partner. How do I get that into Snowflake, right? So there's some work that has to get done to get it in. Somebody got to manage it. Somebody has to go with that. right? Once the data is there, well, how do you transform it? So you run a query, okay, great, but how do you schedule that query? So now we need to bring DBT. So DBT can do transformations for us, or some other tools like Matillion. What about orchestrating and scheduling? I got to run 5 jobs one after the other. If the third one fails for whatever reason, how do I deal with that, right? So that's where we have Airflow. We have other systems that do orchestration. So I'm talking about a lot of different stuff, but that's the reality, right? So like if you talk about, just stick stuff into Snowflake, run a query, and boom, you're done. Like it's really not that simple, right? And when we're talking about self-service in the sense that, any business user can come in and go build a pipeline that just takes the raw data, transform the way that they want to use it, and then use it, it's actually not that simple. And it's funny because I've talked to, I don't know, maybe 5 or 6 customers in the last couple weeks that are building something very similar to what Upsolver did. They basically took, DBT, Airflow, and Snowflake, and they built a user interface on top of that lets users write SQL queries. And then behind the scenes, the system that they built basically creates a DBT model, creates an Airflow DAG, schedules it, and kind of gets it working. So they kind of built the same thing that we built as a product, but now they're responsible for managing and scaling and maintaining that infrastructure that they built. And that's a lot of tech debt.
Yeah, if you have enough people, this might work out, but most likely this ends up.
It's gonna be painful. It's gonna be painful.
It costs a lot of money.
Yeah. So we kind of took that idea. We said, like, look, we want to allow users to bring data in very easily. One of the biggest challenges we've seen is not necessarily in the transformation, but in the ingestion. Because the volume of data can go up, can go down, but many times it's just going to keep going up. Like, how do I make sure that my data is ingested in a consistent and reliable way? And if something breaks, there's some way to fix it, right? There's a notification, there's some observability to it, and then a mechanism for you to fix it. So like the ingestion piece sounds simple, but it's actually really, really important. Like if you don't do this right, then everything else down the road is just it's garbage, right? So in Upsolver, we make it super simple for a user to create a connection to some source, right? Whether it's Kafka, Kinesis, S3, whatever, and then bring the data in. And the way we do it is we always bring the data into the data lake. So whether you want a data lake or not, data lake actually is a huge benefit because it stores a lot of historical data very, very cheaply. And it also makes the data accessible in a scalable way. Because once I put it in S3, I can have many, many systems, many, many threads, many, many clusters, servers hitting that S3 to grab the data, and S3 will automatically scale for me. Like to do that with another system like Snowflake or other database, it's really expensive to do, right? So you kind of get scalability out of the box for free almost, right? The other thing that you get is that you get historical access to the data. Right? Like if I put all the data in Snowflake, I'm paying for that storage. If I put in a BigQuery, I'm paying for that storage. If I put in some kind of database, I'm paying for it. If I leave it in Kafka, I'm paying for that storage. It's in S3, right? It's a lot cheaper. I can move all data into archive or some lower storage tiers, and I can save a lot of money. So there's a lot of benefits there. And then from there, a data user can come in and just say, hey, I just want to take that data that you stage for me in a data lake, and I want to do something with it. I want to model it in a way that makes sense to me. I want to transform it in a way that makes sense to my use case. And then I want to load it into Snowflake because that's what I want to do. Or I want to point to Elasticsearch because that's how I want to query it, right? You have that flexibility. You don't have to go to your data engineer and say, hey, Mr. Data Engineer, I want to model my data this way. And then I want to transform it. And then I want to load it over here. And then I want to change my mind because, hey, I didn't think about this before and I modeled it wrong or I transformed it wrong. I got to go fix that, right? Now it's like, get in the queue, wait. Somebody else is ahead of you. I can do this on my own. So that's really what we wanted to accomplish with Upsolver, with our product called SQL Lake, is to really make that easy for users.
Val has an interesting comment here, and that was also my thoughts. It baffles me as well. there are much easier ways to do data than stitching together multiple modules, or I'm guessing he also means tools. You guys are bang on the target. That's like you said, people are saying, oh, well, then everybody's talking about Snowflake or Databricks, but like the layer of other stuff that you have to bolt onto this is very often overlooked. So,
That's
shit, I know I need this, now I need this, now I need this. And then you end up again with that, not hard infrastructure, but like tool ecosystem where you say, now I need to maintain all this. And have
I mean, one thing that it's funny because we talk about airflow for orchestration. Okay, great. It sounds awesome, and we need to do it. But then what you don't realize is that airflow is actually a cluster, right? Like you actually have a cluster of machines that are running your tasks, right? All the tasks that actually execute and schedule and do things and do operations, like they got to run somewhere, right? So it's not airflow like there's a magic bubble that just schedule my stuff and I don't have to worry about it. Now I got to scale those little tasks, right? And if my DAG gets really complicated and I got 200 tasks inside of my DAG, those tasks have to get scheduled on a cluster. Like, okay, there's systems out there, like Astronomer, et cetera, that give you, managed services, but it's one more cluster. It's one more thing that I got to go worry about. One more thing that I got to go pay. One more things that, I got to monitor and make sure if that thing breaks, then I got to figure out how to fix it. So yeah, it's that. And then not to add more to this problem, but when you look at the world, right, there's also a streaming kind of bucket of systems that are ingesting data. There's also batchy kind of systems. The batch systems are a little bit easier to understand because we've done them for a long time. They're simple. Like it's you take one batch, you transform it, something breaks, you fix it, and you rerun it. With streaming, it's actually a little harder, right? It's a little scarier. How do I get that in there? But we're simplifying it. So Upsolver is kind of simplifying those two and kind of making them both look very much the same to the end user. So you don't have to worry about two different things that are difficult to manage. We just make them all look like one because under the covers, they're not that different.
Yeah. But as you said, like standard, like a batch ETL job, that's something people know for many years, and it's not super scary. But when you tell people, then okay, now let's do a streaming pipeline, then they're coming to you need tools. Then
it actually goes back to Val's point too about the comment that you need all these different tools and modules to execute a batch pipeline, but then the second you add a stream to that, now you're multiplying out your tool set even further exponentially, because most tools designed to handle batch either don't handle streaming at all or handle it very poorly. So now your 4-tool pipeline became an 8-tool pipeline with a very strict delineation that separates the data that you might want to combine. So really good.
And the skill sets, right? Like if you know how to optimize a batch job, it's not the same as optimizing a streaming job, right? And if you know how to recover from errors in batch, you don't necessarily know how to recover from errors on streaming, right? So it's harder.
Yeah, that's true. It's also money-wise. Very often people are a bit scared of like streaming. Oh, this is going to be very expensive. Although I'm not 100% sure.
I don't find that that's the case, right? Actually, what I find? I find that when you talk about streaming, like you typically, you can articulate kind of what your volume is. Like you may go up, may go down. Auto scaling will match that, fairly easily. But yes, this cluster is running 24/7, but you can better optimize for the data, where in batch, you may have a certain SLA that the only way to solve that problem is just throw a lot of machines at it, right? The other thing I've seen is that with batch, it's much easier to not know how to optimize or to not care about optimizing and just throw more hardware at the problem. And that's why people pay a lot of money, is because I don't know how to optimize this job. It keeps failing. So I'm just going to give it a machine with lots and lots of memory, let it run and let it do its thing. But then you end up with a huge bill at the end of the day. And people are like, whoa, AWS is expensive.
Yeah, that's true.
It's not expensive. It's just you're just not being responsible.
Well, Umar brought up a good point there too about startup companies trying to scale up their applications and not being able to predict
this one here?
how much data. Yeah, a few earlier there, Andres. But so yeah, streaming data works really well in those types of architectures because it can start small and you can scale up as your application needs to scale up. Versus, to Roy's point, you know, we're fearful that our batch process is going to eventually need to handle multiple terabytes of data. So let's ensure that ahead of time and sink all this cost into infrastructure that may actually not be needed.
Yeah.
So yeah, these streaming use cases for startups, it's actually a lot of the conversations I'm having with potential customers nowadays are those that are just starting to build out their streaming application architectures and want to ensure that it's cost effective to start, but scalable if and when they need that scale.
Yeah. The cost thing is for me, if it delivers the value, right? Who cares about the cost if the value is there? If you get an ROI on it, of course you have to keep it the budget. But like, who cares if it costs a bit more? If that's the value you want, and it delivers it, so be it.
Yeah,
right.
I think you're right. I mean, the cost definitely matters, right? Because at the end of the day, like if you don't want to go broke, but you know, if it delivers the ROI is the question, right? And you know, when I talk to a lot of customers in the early days of like data lakes, and even now, or even data warehousing, like building a data platform is not that simple, right? And you tend to hear like, let's throw a lot of data at it. We got lots of data. Let's go do something with it, you know, et cetera, et cetera. But then like when you kind of take a step back and you look at the 10,000-foot view and you say, look, what is the ROI? What did I get out of this? Like I spent all this money, hired these people, build a platform. I got gazillions of terabytes inside of my data warehouse or my data lake. What am I doing with it? Like what did I actually get out of it? Very often it's not a lot. Like fancy dashboards, cool widgets and little graphs, but did it move the business? Like didn't really move the business. Like it didn't really have a huge impact like most companies expect. That takes time though. I think that piece takes time and kind of like the ramp up of just getting out of the way of the data platform. Like here's the data platform. Let's build it. Let's get going. And then let's go focus on actually getting value from the data. And you're not going to get value from all of your data, right? You have lots of stuff that's maybe just useless or you can't correlate to anything or it doesn't really mean anything. Maybe you'll use it in the future once you have a different set of data. But, you know, I see companies like spending months and months and even years just building data platforms and adding more tooling and bringing more data in and doing more. And I'm kind of losing sight of what is the ROI? Like, what are you doing with this data? Who is using it? Are you making their life extremely difficult to actually access the data and do something with it? And with Upsolver, like our focus was, you know, a friend of mine kept referred to it as data engineering as a service. And I really love that term because you have a product that is kind of offering you a data engineer as a service, so you don't have to have a data engineer, or you can have less data engineers. Data engineer focusing on like real platform stuff or building the right process behind the scenes, but the tool itself makes it easy for you to just bring data in, transform it, and get it ready for people to start using it. So you go from weeks and months, like we said before, to days, and even less than that, even hours. To get stuff up and running. And that's usually the piece that you want to get to.
I usually call this the mundane stuff, the boring stuff. You don't want to, as an engineer, you don't want to do the boring stuff like, let's integrate this database. And like, you want to make this easy and focus on the problematic stuff, on the model.
Yeah, AWS, we used to call it undifferentiated heavy lifting, right? And it's the stuff that nobody wants to do, but you got to do, right?
Yeah. So we were talking about ROI and a value of data. We titled this data product. So how does that lead into data products? What's a data product?
Right.
How does
exactly. So I think you kind of hit it on the head, right? So we talk about companies building these data platforms and, offering data to their users to consume and do blah, blah, blah. But if you look at the way that these platforms are built today, commonly, not everybody, right? But oftentimes, they're not all that reliable. They're not really designed like we would design our product, right? Like if I'm a company who sells a product, how would I design that product? If you share the screen, I have a picture that I drew of a common way of building like a SaaS product or a service. Of course, it's not to detail, but you can see that there's a lot of thought that went into how do we structure this in a way that's scalable, extremely scalable, can be monitored and logged and alerted, and accessible. And then all the interfaces, all the systems in this path are speaking the same language, right? There's an API. There's an API spec that says if you want, a payment event or a messaging event, you call the API, right? And everybody speaks the same language. And it's not what we have today with data. Like if I go to my next slide, this is kind of what we have with our data platform today, right? It's, there's a bunch of microservices behind the scenes. They got some databases, SaaS providers, whatever that may be. And then we find a tool, whatever we want, whatever out there, Fivetran, Airbyte, whatever. And then we just suck the data in. We stick it in either into a data warehouse. Sometimes we stick it into a data lake, right? There's no really design best practice here that's common. It's just stick everything into a data lake, then maybe copy into the data warehouse or put it into the data warehouse and then copy it into the data lake. There's no standard schema. There's no validation of data quality. In a data warehouse, I typically model my data, but in a data lake, I don't model it. You may have duplicates across. And then if I go to query the data in a data warehouse, there's certain SQL dialect that I'm using, right? Like Snowflake, Redshift, they have certain, it's all ANSI SQL, but they have their own functions and dialect. But then when I query the data in a data lake through a query engine like Presto and Trino or Dremio or Starburst or whoever, that dialect is also different, right? Yeah. So, and then discovery, like where do I find the data? If the data is if partly in a data warehouse, but then partly in a data lake, then I need to go to two catalogs to find it. How do I join between the two? Now I got to move the data. So it's very kind of chaotic, right? There are no guarantees. Like I don't know if the data that I'm getting is the most accurate, the most fresh, the best quality, who owns it, right? And this is something that the whole idea around data mesh is really trying to address, parts of it, right? Like ownership. Who owns the data? They're responsible for the schema. They're responsible for the quality of the data. They're responsible for making sure the data is discoverable and accessible and secure, right? So those are all things that we've kind of identified and we've done in our SaaS products, like the regular products that we have. Like we know what security looks like in this model, right? We know who has access to what, which APIs can call what. We know that APIs are using the same API spec. We don't just randomly change the API signatures because we added a field. Like there has to be some kind of backwards compatibility. There has to be some validation period. There's processes that go into it, but we kind of lack that in our data platform. And that's the piece that we're trying, I think, as a community to kind of address and resolve. And data as a product basically says that let's start thinking about our data platform and our data as we did with products, right? Have some guarantees. Let's there's a lot of talk about data contract and what's a data contract, right? It's schemas plus some quality validation plus some SLAs, right? Now we're starting to put some rigor and some control into what this thing is, right? So like there's lots of definitions of what a data product is. This is just one answer that I use of what a data product, but it's really about being able to deliver reliable, accurate, and fresh data to the business, but treating that data as you would any other software application or service, right? You're not going to go launch a software product or service without an API or without a stable API. You're not going to do it without security, without the proper ways of deploying code using CI/CD and tests and things like that. But yeah, we tend to do it with data, right? So we're kind of focusing on best practices, identify what those are, build those into our tools, making sure our tools deliver the best practices and not forcing users to know what those are and to learn those and to practice them. Like, yeah, there's some things that the user have to practice, but for the most part, our tools should be able to do this on our own, right? Standards, right? Like, what is the data contract? Like, what is the schema between the producer and the consumer? Like, we can't just change it because things will break, and that's no longer responsible, right? Like, that's not what you do with a product today. Like, if Salesforce decides to change their API tomorrow, they're going to break millions of applications out there. They can't do that. Right?
I think Apple does that regularly, where they with
and
their
it doesn't
iPhone,
piss everybody off along the way. But it's yeah. Go
ahead. I think that, can you go back to the last slide? Yeah, that one. So, because that's actually the problem, right? Especially on the left here, where you have payments, messaging, and inventory, and so on.
That's right.
If they change something and don't treat it as a product, but like they do what they want, then you're running into big problems.
Yeah, but again, you may have changes on the left side, right? So if the payments team decides, hey, we need to capture another field, or we forgot a field, or we need whatever, right? They're adding another field. That's okay. That's part of the business. There's no issue with that. But how we bring the data in, how we model and how we present it back to the consumer, that smiley face on the right side, needs to be consistent. Like, we can't just say, the user on the right side can't just run a query today and say, like, oh, wait, there's another field in here in the payments table. Like, how did I even get there? What does that mean? Like, somebody has to say, hold on, you want to bring it in, you want to have a new field, no problem. We can ingest the new field in, but we're staging that new field. Like, we're putting in a staging table. But what the user is presented is a modeled view of that staging table. And that model can either include that new field or can exclude the new field until the contract is updated, until the schema is updated. And you go back to the user and say, hey, I have a new field in a payments table. If you want to test it out, I got a staging table over here that includes it. You can test it out, try out your dashboards, and then when you're ready, you can flip to the new one. Or have some kind of process that tests and validate before you just flip the switch, because otherwise you're going to break a lot of things down the line.
I think Roy's point is a good one too there. Back to your question, Andre, that the left-hand side of that screen, you need to expect that that's going to change. I mean, in today's world of semi-structured or unstructured data and data coming off of streams, like, those platforms are designed to handle unstructured or semi-structured data. So that needs to be something that is baked into your data product or your data pipeline, from the get-go. You can't have a pipeline break just because a new field shows up in a payment data stream. There's one customer I'm working with right now. It's a single application and a single type of data, but it's coming from different regions. And one of their use cases, they want to effectively merge data coming from different regions into a single view of their business. And different regions have different requirements around what needs to be tracked. So even though it's one source of data from a functional perspective, right? It's one type of data that's coming into their pipeline. It's coming from so many different regions that data is going to always be different and always be changing. And it's something that's really difficult for them is how do we model and how do we productize that incoming data that just by definition is going to be different and changing?
Yeah. So I just want one thing about Upsolver. So what we said the usual way, or what a lot of people do is, can you stay here?
Oh yeah, sorry.
so you bring in you have something like Airbyte or other tools, and you bring in your payments or your messaging. You bring that in the warehouse. You just integrate everything there, and then do your transformations and all there, right? But that's actually something where you are, where you're changing this process, where you're picking up, right?
That's right.
Can you explain this on this image a bit?
Yeah, so you can kind of think of Upsolver, and I probably should have drawn this in here, but you can kind of think of Upsolver as sitting between the left side, the services, the microservices, or the inputs, and the outputs, which is your data warehouse and your data lake. All right, so like where these cross arrows are, that's where you'd see Upsolver come in. So we can either read directly from those systems, like pull from a MySQL or Postgres or Kafka or Kinesis, or if you're using something like Fivetran to read from, from SaaS providers, we can take the output out of a Fivetran, and then your staging of the data gets done in your data lake. So you always have a place to store that raw data. The transformation, materialization, the joining, etc., is kind of done in real time. And then the results is written into your target, right? Whether it's your data lake, whether it's your data warehouse, but you're consistently writing the data the same way. And you structure your schemas in a way where on the ingest side, it's going to be dynamic schema inference. I don't know what's going to come in. I just want to take it as is. So I bring my data into my staging table, and I continuously update my data. Now I have inside of Upsolver, like I set up a separate job that looks at that source data that's coming in and models it, right? And there's a specific schema. There's a static schema that says, this modeled view of payments has these 20 columns in it, for example, of these different types. So I'm continuously reading from the source staging table, materializing the data, and writing it into my modeled table, and that's what my consumer is consuming from. And we'll see that in the hands-on workshop. We'll kind of talk about how we do that. So the input, the schema will be dynamic, can change whenever somebody changes stuff. We then have a static schema that is modeled around what the business needs to see for the payments or for the messaging or for inventory or for whatever. And then from that, users can sort of create like marts. They can basically build their own jobs using SQL, of course, to read from these model table, join them, aggregate them, do whatever they want with them, and then write the results again back into a data warehouse, into a data lake, right? Now, in our case, in Upsolver, data lake is used as a persistent store for all of those things, right? So a staging table is in a data lake. I can put my intermediate tables, my model tables in a data lake. I can even put them in a warehouse if I wanted to, and then have the user build the marts in the warehouse, or I can write the data into the data lake and then have the user build the marts on the data lake, or even build a mart in Upsolver and then push it into the data warehouse.
Yeah.
The benefits of doing the transformation of the logic in that central location, again, whether it's Upsolver or you decide to do with Databricks or Spark or something else, the model still is the same, right? In our case, in Upsolver, we're just making it easier because it's the same platform, the same language. It's very easy to kind of understand what's going on, but you can build the marts in Upsolver and then write the results, right? Kind of the KPIs, if you may, into your data warehouse. Right. So we see that sometimes with like feature engineering in machine learning, where you want to do your feature engineering in Upsolver, which gets done kind of in real time. And then the features, right, the output of that feature engineering goes into a data warehouse or goes into, some other database that you want to, query when you're doing your inference.
Yeah, because it's also, you mentioned this in the beginning, or earlier, it's the right word. Also the data warehouse storage, that's going to cost you a lot more than the data lake. So it's actually having something built around the data lake is really beneficial.
Yeah, it's much more efficient. Yeah, and the thing that I've noticed too, and if you keep, typically it's like, okay, well, my source system can keep the history, like, oh, Kafka can scale and blah blah blah, right? But the persisting data in Kafka is actually expensive because you got to replicate it, right? And then you got to have some storage in S3, and then you have some cached. Like if I ever want to replay and somebody says, oh, wait, we had a mistake, we got to go back 6 months and we got to correct a tax issue or correct a whatever problem there was. I want to go back and enrich the data again. Like, am I going to keep 6 months worth of data in Kafka to go back and replay?
Most likely not.
Right. So but I can easily keep that in S3. And that's a very powerful feature of Upsolver. And that, I'd say pretty much all of our customers use this, because you always have to replay. You always have to fix something. You always have to enrich something. You always have to update something. Now, the question is, in today's world, I can't go back very far because I don't have the data. Because I don't want to maintain the data in Kafka or maintain the data in my SQL database. But in Upsolver, when we stage in the data lake, you can keep as long as you want, right? We can always go back to as far as you want. The other challenge that you have too is in a batch world, if you're doing kind of real-time joins and aggregation, right? So as data flows in and you're joining and aggregating kind of in real time, if you were to replay or redo that process in a batch, it's actually very, very difficult to get right? And that's one of the challenges that we've seen with our customers all the time, is that because I'm joining stuff as new events come into this table, new events come into the second table, I'm joining them together in real time and I'm aggregating them. How do I replay that in a batch world, right? Things aren't synchronizing, and then you're going to end up with bad results. So that's something that, having a real-time platform like Upsolver makes sense. And because Upsolver takes batch and real time and kind of all make it look like real time, we kind of eliminate the need for you to think about these two different models, and just makes the whole thing much easier.
And this is a really important topic. We'll touch on this in the workshop, but the last two comments that came in were exactly along these lines about correcting of data and having to backfill results and having to add new fields to outputs. And what if the data is not on the source stream anymore? Exactly what you mentioned, Roy. So it definitely resonates with your comment that's something that a lot of users are struggling with.
Yeah, that was something I saw these two comments as well. That was something I want to ask you as well. Like, I'm guessing this is something that is, let's in quotes, your way, that it's a lot easier than the traditional way of batch processing and so on. Like having a new field and then you need to bring it in and bring the historical data and basically the refilling. I'm guessing this is also a lot easier.
Yeah. Jason, do you want to take a shot at that question?
Yeah, I mean, we'll show it to you in action. Obviously, our workshop's not going to work with 6 months worth of back data, but we'll try and at least demonstrate how that would work. But the I guess the Cliff Notes version of it, if I'm going to jump ahead into the workshop a little bit, but it's Roy mentioned reading data off of a source, whether that's staged S3 data or a Kafka topic. When you set up those data ingestions in Upsolver, we're reading that data as a stream minute by minute and effectively near real time and bringing that into the data lake. So let's say you've been reading off of this Kafka topic for 6 months, and 2 months ago, a new field started showing up and nobody told you, right? Nobody told the data engineer that we were going to start writing this new field. This goes back to Roy's comment in the architecture. Like, we should expect that those data sources are going to be evolving and changing as they develop their applications. But 2 months after that new field started showing up, someone went to the data engineer and said, all right, we need to now consider this new field in our data pipeline. All right, we need to build some analytics around it, or we need to add it to some output table. But we only keep 24 hours worth of data on our Kafka topic, right? For cost reasons, maybe it's a week, maybe it's 24 hours, but it's certainly not 2 months. Maybe it is, but in many cases it won't be. Well, the good news with Upsolver is that we've been reading that Kafka topic for the last 6 months. So once that new field started showing up, we started pulling it in, and it's now in your data lake, and it's optimized and stored within the staging table. And Roy will show you what a staging table looks like here in a few minutes. so that when it comes to adding that field to your data pipeline, it's as simple as writing some transformation logic via SQL. And then when you create a job in Upsolver, you can backdate the processing time. One of the comments referred to it as backfill, but with us, it's just saying, start running this job from 2 months ago, right? When that new field started showing up in our staging table, and then the job just starts running from 2 months ago and starts processing that data has been ingested and stored in your lake. And that new field starts showing up in your output, as that new job processes. So it's, we're going to show you an example of this as we go through the workshop of, our example is a little bit different. It's about a data correction. I don't want to, I'll foreshadow a little bit. We're going to notice some bad data that came and we processed unknowingly, and now we need to go ahead and correct it. But we'll go through the process of how to do that. And it's in Upsolver, it's as simple as writing some SQL with a job and then just backdating when you want that job to start processing.
Yeah, it's the same process basically. Like whether it's bad data or backfilling historical data, it's the same. It's the same thing. We basically take your job and we tell it when to start and when to end. Right. So if you want to go back 36 weeks, then tell it what's the date 36 weeks ago. And how far to go. Like, do you want it to keep going till now, or do you want to stop 36 weeks plus X number of weeks? Like how much do you want it to go? Kind of like shift that window, and then we process and we backfill that table. So yeah,
what's really nice compared to some more batch-oriented processes when you go through use cases like this is you're not really worried about what jobs do you have to stop and which job, how is that going to affect downstream, and do I need to go and delete some files because they have bad data in them? It's a really kind of streamlined, I was going to use, which maybe misusing a term there, but really streamlined process to kind of modifying those pipelines without having to spend a lot of time and effort in the orchestration piece of it.
Right.
So what does this mean for data engineers in the future? So are we going to lose our jobs with this?
No, I don't think so. I mean, honestly, there's lots of talk, and this is always the case. Like, not that data engineering is not alone, but it's always about, hey, what skills data engineers need to have? Like, what tools should they learn? What best practices? I'm of the opinion that best practices are something that our tools should give us. Like, it's not something that we should be doing and learning all the time. Like, there are new things that we will always be ahead of the tooling, but ultimately when we want best practices to be addressed by the masses, like, our tools need to do it. I'm not going to go train my entire company about using Parquet format or partitioning their data, or like it's pointless to ask them to do that. Like, the tool should just automatically do it. But I think it's the data engineer's role is really around kind of like bringing in the data, making sure that our ingestion, our ability to bring data in is really scalable and resilient and powerful. Just like software engineers today, kind of building the best practice, building the development tooling and infrastructure around our data pipelines so that users can contribute on their own, right? To make it easier. Like, software engineers will build the process, they'll build the application, they'll build the service, but it'll make it easy for other users in a company to contribute code, to contribute features, to participate in that. Like, we're lacking that right now in the data world, right? It's kind of like everything is dependent on data engineers. It's like a single-threaded bottleneck, if you may, to the data platform for it to be successful, because everything has to go to the data engineer because other people don't know how to do it, right? They don't know how to touch the systems. They don't know how to write the code. They don't know how to scale it. Well, we got to make it easier, right? I think DBT did a really good job at kind of abstracting away the complexities of our data platform by saying, like, if you want to model something, if you want to put something in a data warehouse, just write SQL and DBT, run DBT test, DBT build, and then you're done, right? But this abstraction is also a bit difficult because if you do something wrong in DBT, then it reflects on the warehouse, right? That we see a lot of this, like, DBT code is just unoptimized in Snowflake and it's not doing a good job. I'm sure they'll fix it. I'm sure they'll do a good job at that. It just, that comes up all the time. It's not anybody's fault in particular. But I think that's a good way to think about it, right? Like DBT is that thing that kind of like makes it easy for anybody to go and build stuff. And I think Upsolver is doing something very similar, again, with SQL, but we're doing it on top of a platform that's both batch and streaming, and has a specific engine like the Upsolver engine that lets you do all those things together. And the benefit there is you kind of reduce the number of abstraction layers that you have. Like one thing, I get this asked all the time from customers, like, hey, we have Databricks, and Databricks has Delta Live tables, and it's SQL, right? Like, okay, but it's SQL on top of Spark structured streaming, which is on top of kind of like the Spark core engine, which is on top of Databricks cluster manager and the scheduler. And if something breaks in your SQL, well, now you have like 5 levels that you got to go troubleshoot and understand. And if you ever looked at the Spark logs for that, it's not simple, right? And the same thing with KSQL DB on Kafka. It's SQL, but it builds K tables and K streams, and then it runs on top of the Kafka clusters. But KSQL DB runs on a separate set of clusters. How do you troubleshoot that? Like, we keep putting these levels of abstractions, which are great, simple to the user, but if anybody has to fix anything, forget it. That's like, you got to be a rocket scientist to be able to do it. With Upsolver, it's SQL, and it kind of rides on top of the metal, right? On top of the Upsolver engine. We expose everything actually through tables. So you can actually run a query against our task table and see what the tasks are doing. If it's a compaction task, if it's an ingestion task, if it's a writing to storage task or a write to Snowflake task, you can see all those things and you can troubleshoot them on your own as much as you can. But there's visibility. There's ability for you to very, very quickly see what's going on.
But you don't necessarily need to be an engineer for that.
Right? No, exactly. It's a select star query on a task table, and you can see what's going on. Now, you may not be able to fix everything, right? But at least you know what's going on. Like if your Kafka cluster went down, you'll see very, very quickly that there's no events. There are no events coming in, right? You can go point to the data engineer and say, hey, Mr. Engineer, like I need you to do this. So anyway, that's kind of the gist of it. I did want, actually, before we move on, I know we've talked a lot. So before we get into the hands-on stuff, I did want to kind of show a picture quickly of kind of what the architecture looks like. So hopefully it's a little clearer once we get there. Can you share the screen?
Yes.
All right, awesome. Cool. So for the workshop, we'll bring in a couple data sets. They're in S3 in this case, but they can really be anywhere. Order data and sales data we're bringing into Upsolver, and then we show like 2 different steps. We'll show kind of the data engineering step, the ingestion and the staging, and that's going to go into the data producer account, if you may, the data producer catalog, as you can see, catalog A. And then we're going to have Jason come in, and he's kind of the data analyst. So he's going to take that raw data, he's going to model it, refine it, join and aggregate it, and he's going to do it all inside of his account, inside of account B, right? So that's kind of the separation between the producer and the consumer. They don't all need to live inside of the same AWS account using the same AWS resources, but within Upsolver, it's the same platform. The user doesn't know any different, right? But the raw data is in a producer account, and the refined data is in the consumer account, and then we'll kind of show how that comes together. All right.
Okay. Yeah, it makes sense, of course. Usually you don't have, like, somebody is responsible for the part where the data actually lives right now, for the source, and then you have someone who actually wants to do something with it.
Right.
Yeah.
Okay. So let me actually share this screen over here. All right. Making sure it's, so I won't get into a lot of the specific details on kind of like what Upsolver is and like the UI and stuff, but at a high level, we have this concept of worksheets. And these worksheets are just blank pages that you can write SQL in, or you can actually start with a template. So we actually, for this workshop, we started with this template right here. So it's called Join Two Data Sources using sample data. You can kind of go through it and see what's in it. But generally, we kind of took that idea. We enriched it a little bit, added a few things. But if you wanted to follow along, if you wanted to kind of implement a similar use case to what we're doing here, you can just simply come into Upsolver and execute, use this template, click use template, and then just go execute it, use the sample data, so you don't really have to worry about connecting to your own buckets and those kind of things. So as you can see here, we have 3 worksheets. The one I'm going to look at is the S3 ingestion one, and then the other ones are the ones Jason's going to look at. So I'm a data engineer. I'm coming into the platform. I want to ingest a few data sets. I want to stage them, and I want to get them ready because Jason and the rest of the analytics team is going to want to consume them in some way. So hopefully the screen is big enough.
Yeah. Can you zoom in a bit?
Is this better?
Yeah, that's better. It's getting better.
All right, awesome.
Because this is inside the.
yeah, I got you.
Yeah, cool.
All right, so this is actually very simple. So this is I'm as a data engineer, I'm focusing simply on connecting to my data sources. In this case, there is 3 to keep it simple. I'm going to read the data from S3, and I'm going to transform the data. So I'm going to convert to Parquet. I'm going to partition it. And then I'm going to stage it in my data lake, because that's where we want to stage the data, because we want historical data, blah, 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 the things we talked about. But Upsolver is going to do that kind of in real time. So as new data arrives in S3, new objects, Upsolver recognizes that, picks those objects, transforms them, writes them back into the staging table. So there's a couple of things I want to do. The first thing I want to do in line 15 through 18, this is where I'm actually creating a connection to my S3. So this connection does really one thing. It gives you a way to define your credentials. So in this case, I'm using IAM role. I can put in access key, secret key if I wanted to, but this is just a container of credentials. Now, you create this once that's created, you don't really have to do anything else. So many times what we see is like a data engineer or even a DevOps engineer, somebody who understands the AWS environment, will come in and just create that connection because they may have an IAM role. Okay, so data engineer, data consumer doesn't need to do anything with IAM. A DevOps person, system person comes in, run this one query with the IAM role, and then we're done. We have the connection. Now, in the navigation tree here on the left, we can actually see that we have the connection. It's called Upsolver S3 samples. We can click on it. We can see there's a bucket underneath it. There's a bunch of folders underneath it. So we can actually discover what's there. We can see under the orders bucket, it's highlighted because there's a job that's using it. So we can see load orders raw data from S3. There's a job that's actually reading from this bucket, from this folder. So it actually tells me, hey, this folder is being used by somebody. It's not just randomly there, nobody's using it. Actually, it tells me somebody is using it.
Usually you would not see this, right? If you use all other tools.
That's right.
Everybody's like, they're creating their pipelines and they have their own jobs, and like, who knows who's doing what.
That's right. You may have a lot of buckets with similar names or folders with similar names. Like, is this the finance data? This is finance V2 date, blah, blah, blah. Like, which one do I use? In this case, I already know that, hey, there's a job on this and there's another job on this one. So these are the ones people are using. I can actually click on this job and I can expand it, right? And I can see, hey, Roy modified this, Roy's created this. So if I have a problem, I can go talk to Roy and I can say, hey, I see you have a job off of that bucket. What is it? Is it good? What's going on with it? I can see the actual SQL that Roy wrote for this job, right? So now I got some accountability. Like if Roy screwed something up, I can come in and say, hey, Roy, I see what you're doing here, but the way that you're ingesting the data is wrong, or you're doing something wrong. So there's some accountability to it.
Or if you just have questions about the data set or the data that is laying around, you can look. And that's what for me has been missing a lot. like you have the data somewhere, but who is responsible for it, or does somebody do something with it? And this way you see, okay, somebody's already using it. Let's look what this person is doing, and let's maybe have a chat and have some collaboration on best practices of what to look for, what's dangerous in there, and so on. Right?
Yeah, exactly. So it's about ownership, it's about transparency, it's about sharing, right? And you'll see later when Jason comes on the platform, like how he sees the things that I created. So now that we have the connection, the next thing we want to do is we want to create these tables. Now, as you can see here, like these tables are being created in the Glue data catalog. So by default, you have a default Glue catalog, as you can see here. And it shows my database, my tables. We'll get into that in a second. But what I'm doing here is you can see that I'm saying create table, and I'm not giving it any columns. So I'm not defining a schema. So this automatically tells Upsolver that schema needs to be automatically inferred and created in the catalog, right? So this is the automatic inference, automatic schema evolution. I don't really have to worry about it. The other thing is that we have this partition by. So we're telling the table that it needs to be partitioned by a particular column. In this case, I'm using a system column because there's a $sign in front of it, because my raw data doesn't actually have a column that I want to partition on, right? So many times, and we see this often with customers who already have a lot of data in S3, and they never thought about partitioning as a new concept to them. Like, well, what column are you going to partition the data on? Well, I don't have one, right? So do we have to recreate the entire data set and insert a new column to it? That's going to be a lot of money, a lot of time. So when we ingest the data into Upsolver, we automatically inject several columns that you'll see in a second. And one of them is this event date that you can use to partition, right? So this is when the event arrived in Upsolver, we put a date. Now, if the event date was there already because it came from Kafka, we can just use that if we wanted to. But if you don't have one, we automatically insert one for you. So, okay, so we create two tables, one for the order data, one for the sales info data. This is our raw staging data. So we created, I'm not going to execute it again because it's just, it takes seconds, but there's no point of doing that. The next thing we want to do is we create these jobs. And there's two of them. They're very much the same. We call this a copy from job, but you can think of it as an ingestion job. Really, all it does, it does a copy from the S3 connection that we defined. So now that tells Upsolver, use these credentials. We want to select from this bucket in this folder, right? So you can see here, there's this folder here, right? And then we want to insert the data into our table that we created in the step above, right? So first we create a connection to S3, then we create a target table that we want to put stuff into, and then we create a job that reads from the source and inserts into the table. And that's really all you need to do to ingest the data. Now, this can be, 10 gigabytes. This can be a petabyte. This can be 100 terabyte. This can be a Kafka stream. This can at 10 events a second, 5 million events a second. From a user perspective, it doesn't matter. This is really all you need to do. Like in the Spark world, if I'm reading from S3 and I'm producing a table out of it, if it's a terabyte, okay, cool. If it's 10 terabytes, 100 terabytes, now I got to start doing partitioning. I got to start doing different tricks inside of the Spark code to make sure that it's partitioned properly and it's distributing the data across the nodes properly. I got to orchestrate it and schedule it. Like, you don't see any of that here, right? Mm-hmm. There's no optimizations. There's no orchestration or scheduling. Everything is handled for you behind the scenes by Upsolver. So once I run this job is running. So we can see here the orders raw data. If I go into my table, I got my orders raw data right here. Actually, let me just go back here. So this actually shows me that there's a set of columns because we automatically infer the data. There's some nested fields in here. We can see there's two jobs. So there's one job that's this one is the load orders raw. So we can see it here. So we can see very quickly that the job is loading data into this table. We can click on, let's click on this one. we can actually see, we haven't ingested any events recently. Actually, there's a few events, 4K or so. So you can actually see here that events are coming in. If there's a spike or a dip, you'll see right away. So if your Kafka cluster or your job is producing a steady state of events, but there's a drop, right? You'll see the drop here. We also see some value distribution, so we know what values are there. If there's like a skew in our data, you'll see that very quickly right here, right? You'll be certain values are much higher percentage than the other values. So you can detect data skew very, very quickly. You can also see that the density of the event, right? So if you have null values, your density will go down, right? So this tells me that there's 100% of the data is real data. But if there's no values injected into it because of some mistake, some error, this value, this percentage will go down. So you can very quickly say, hey, some null values were introduced to my column. I need to go fix that problem. The same thing goes for your table. We can click on that table. We can actually expand it, and we can see there's data coming in, how many fields you got. We know one of them is a key field, like a primary key. There's some arrays in here as well. We can go in here. We can see some values, things like that. There's also these two columns here that are really interesting, the first scene and the last scene. So, this is actually saying like how often are these column schema changing, right? So the first time I've seen this column was 6 days ago, but the last time the column was modified was like 2 minutes ago, right? So if I change a column type or something happened, I will see that here, right? So if you're pretty steady, nothing changes, these values will be fairly large. But if somebody introduced a new column, you were not aware, nobody told you about it, you can very easily see it here and say, hey, the first time I saw this column was actually today. Hey, maybe somebody introduced a new column into the payments table, right? So
that's what Umar mentioned earlier, like handling new
right.
fields.
And all that happens without having to modify the data ingestion job, right? The job's just been running persistently. We created it 6 months ago. It's just been continuing to run, pulling data in, but we just saw a new column go up a few months ago. That's where, where Roy showed you, that's where you would be able to visualize that.
Can you, just out of interest, can you set alarms for this stuff?
Good question. Not yet. That's something that we're working on. So all those things will be able to be alarmed. So you can set alarms when things last seen, first seen. So we're adding support for that, but not at this moment, no.
Because that's a cool feature to have that.
Yeah, absolutely.
I get it. It's something for the future.
Yep.
Okay.
But again, you get kind of like basic data quality, data kind of observability aspects of it. You get some data profiling. Like here, you can see there's only 4 values in here. So there's a lot of information here that's valuable for the user. As for a data engineer, if I'm ingesting data in, I can see, do I have the right columns? Are there the right types? Is the values correct? Do I have any null values? Maybe I'm ingesting stuff and for some reason the data is null, like, okay, something broke. I need to fix it before I give it to Jason. Like I shouldn't just throw it over the fence to him without taking care of it first. So this gives me a lot of visibility into what's going on. I do the same thing here with the sales info data. Nothing really different. And then the other thing that you can do from within Upsolver is you can actually run queries against it. Because the data is in a data lake, we actually we give you the ability to write SQL queries. We execute them on Amazon Athena, which queries your data in a data lake. So if you wanted to define cost controls on Athena or work groups or those kind of things, you can do that in Athena to control it, but then you execute the queries here. So, I'm going to just execute this particular query, and I can see when the event date arrived, and then I can start seeing my data, right? So this is just, raw data. This is JSON data, hasn't been parsed yet, but we ingested it in, we detected it. We detected it's a nested field. We broke out all the fields into individual elements, as you can see in the schema. And there's a bunch of other information in here, like the file last modified date. Right? This is something that you typically only can get from accessing the S3 console or the API. But what if I wanted to know, which files were added to my table and when were they last modified, right? So I get the last modified, I get the file name, I get the file size, which is really hard to get unless you go to S3 directly. Many times we get questions from customers to say, hey, how big is my table? Or how big is this particular partition? Right? How many files do I have? How big are they? Right? Well, sorry, you got to go to S3 and you got to run an S3 list command and see how big those are. We capture them as system tables inside of the staging table, so a data engineer can actually go and run some of these things directly by using SQL. And then you got the rest of the data for that particular table, nothing that exciting. So I can create a data, I can look at it, I can profile, I can do whatever I want with it. Some things that I want to do maybe as a data engineer, right? Maybe I want to run this query that kind of looks at my file sizes and tells me how big are the files. So I have close to 10,000 files. There's a total of around close to 300 gigabytes of data in my table, right? So that's a simple query that I can run that tells me how big my table is, like right away.
Very simple.
Yeah. So this is a common thing that I see with data engineers. Like, hey, is my table growing? Is my table not growing? It should be bigger than this. Like, why is this not big, right? Oh, events didn't come in, or the events that I was expecting to be, a gig worth of events were actually half of that. Like, you're not going to know that in advance. Like, you got to be able to go to S3 and look at it. You got to go look at your Kafka stream and see how big are the events. Let's add them up. Like here, I can just run a query against it, right? And I can see exactly how big my table is. I can look at the partition of last hour, compare it to this hour, and see what the size of the partitions are. And that tells me, do I have enough data? Am I missing events? Those kind of things. So this is a really powerful way for data engineers to get quick visibility into what's going on with their data. You can run other commands, like a lot of stuff that you can do here. Kind of looking at my file names. When was the last time they were modified? How many files? How many times we modified that file? So you can see, because we're doing compaction and we're constantly updating the files. So new data is arriving. We're compacting them, making them bigger. So you can see, this file was changed 700 and some times. This is the last time it was modified. If files are not changing, or they're not changing, they haven't changed in a long time, you can say, hey, compaction is broken, or no data is coming in, so there's no need to compact anything. So there's some ways that you can kind of slice and dice your information to be able to be an efficient data engineer, and you can kind of understand what's going on with the data. So that's pretty much it. That was what I wanted to show as a data producer, a data engineer. So this is kind of like my task. So now I can, if I wanted to, I can go create a whole bunch more jobs like this that produce these staging tables, right? So you can see here, those are all staging tables available for my users to consume. So I'm going to stop sharing my screen now, and I'm going to hand it over to Jason to share his screen.
I have one more question before you stop sharing.
Sure.
So you created these jobs here. Where can I see the jobs in this?
Oh, yeah, good question. So you can see the jobs that are running on the table. But if I wanted to monitor my job, I go back to the main screen, I click on jobs, and I can see I can see my monitoring here. So I know they're running. I know there's no delay. There's 1 minute delay. That's not a delay. But if a job is stuck for whatever reason, it's processing taking too long, you'll know right away that it's delayed. So if you're wondering, hey, why is my data fresh? Well, go back here and you can look. Oh, we have a 2-hour delay in the data for some reason. You can see events over time, which is a cool graph to see. Like if you see a dip all of a sudden, like, oh, problem. But then I can kind of click on this. It's pulling a bunch of metrics. Give it a second here.
While this loads, by the way, guys, put your questions in the chat. I'm guessing you have also questions about this. We're going to answer them.
So you can kind of see that the job's running. It tells you what cluster it's running on, how many events were processed, what's the processing rate, right? How fast this thing is processing, which is really important to know. Like, is this thing going to finish on time, or how's my Kafka stream coming? We don't have any errors. There's no processing backlog to worry about. We can look at this. We see that over time we had some delay in processing. Actually, so we had some delay from the source itself. Like reading from the source took a while, and then ingesting it. So there's some delay, but for the most part, it's fine. There were no real issues on our system, or there were may have been some errors, but we handled them, like events that we handled. Cluster utilization, not much to really worry about. And then if we had any errors over time, this will show up here. If there were specific errors, they'll show up here, right? So for example, like if you're using a primary key to insert into a table, if you're trying to insert into a table but the primary key is null, right? For some reason there's no ID, or it's null. Like you see this as a parse error, right? You see it here, like, oh, we didn't insert that row because that value was null. Or, we went to write an event to S3 and it failed for some reason. Like you'd see them here. We also, like I said, we also have system tables, so you can actually run some queries. So we actually have a worksheet with a bunch of sample queries that you can run to give you different views of the data. So you can actually troubleshoot your data in different ways. If you want to understand, hey, I see that there's delay in my data. I want to know what task specifically is causing the delay. We have a query that you can run. It tells you exactly what task is causing the delay. Or if you have an error, show me all the tasks that failed with an error. So you can very quickly get to the bottom of it. Here's the processing errors.
And then you can say here, you can also stop the jobs, I'm guessing here. So
that's a good point. So jobs themselves, once you run them, they're running. Okay. So there's no, like I said, there's no scheduling of them. There's no orchestrating them. They're just running. If there's dependency between them, that's funny. If there's dependency between them, we manage the dependency. So if you do a select from one table, join with another table, the SQL query already knows that, right? So there's no need to tell us again, finish this job and then run this job, right? We already know how to do it. So once they're running, they're running. If you want to stop them, you can do a drop, right? You can drop a job and then it'll stop it. All right, let me pass it on to Jason because I talked a lot and I want to make sure he has enough time.
Cool. I think I shared my screen. I'm not sure if you can push that live. Awesome. Yeah. Cool. So yeah, I'm kind of picking up the use case here from the data consumer perspective, right? So Roy, as a data engineer, has ingested data, staged it, made it accessible to me. Now me as a data consumer analyst, you could put a variety of titles on me, now has to kind of turn this into a data product, right? So I'm going to open up my sales analysis pipeline here. And my product's requirement is that I need to create a data app or a data product that shows sales performance by employee, right? So Roy has ingested 2 different data sources for me. Again, they're in his Glue catalog, which I can see here, the orders raw data and the sales info raw data tables that he's ingested for me. And I can view the data sources here just as Roy was doing. So I've got full visibility into those staging tables that he's created for me in his Glue catalog.
Yeah.
Now, again, both of these came from S3, but one of these could have just as easily came from like a Kinesis stream. It doesn't matter to me, right? As a data consumer, it's just data. They're tables, right? So whether they came from S3 or Kinesis or Kafka or some CDC source, it really doesn't matter. They're tables, and I can now work with them as I would work with tables using SQL.
Can you zoom in a little bit, Jason?
Yeah.
Zoom in a little bit more.
Let me go to code.
How's that?
Is that better?
Can you do one more?
Yes. All right. Let me clean up a little bit. All right, cool. So we've got these tables here. They're both staged as tables. Again, I have visibility into the jobs that created them as well. So to Roy's point about transparency earlier, as an analyst, I can verify, where did this data come from? How long has it been reading data? Who actually created the job to ingest it? So I have visibility into all those things that are important when understanding how this table was populated and what is actually doing that population. Right now, as I start to kind of discover the data, we've got our raw data table. I see an order ID here within my sales data. I also see an order ID, right? So the data person in me starts to think, well, these are probably related. But because I can query these staging tables using the Athena connection that Roy spoke to earlier, I can verify that, right? I can just run a simple select. I'm just going to join together those two tables on order ID and just verify that I have matches, right? Before I assume that these fields are related, let's actually verify that. So sure enough, the join matches, we get order IDs in both tables that look good. So knowing that, now I can also create connections to my Glue catalog. We've already done this. That's actually what this sales ops catalog is. Some of you might have noticed that earlier. That's just a separate connection to a Glue catalog that we're going to use for processing and storing this data. This could all be within the same company. We have a lot of customers that work with clients. Maybe they're data producing customers that now have to provide data products to their end user clients. So this could be their data catalog, right, that we have access to and can push data into. But we've got our catalog created here. And now we're going to go ahead and create the table that we're going to store our data product in, right? So it's very similar to the statement you saw Roy create. We're creating a table in the sales ops catalog. We're not defining the full schema of the table, but we are defining two fields, one that we will use as a primary key. This order ID column is a primary key, and that is going to become especially important later. But for now, just as any primary key, it enforces uniqueness in our output table. And we're going to partition this data by order date, right? So order date is the date that the process was ordered. So pretty simple, straight table statement that we use to basically store our data product in. Now, because we're working with two different data sources here, we're combining two data sources. We're going to create a materialized view on one of them, right? So a materialized view, it's a pretty fundamental database concept that Upsolver uses to create effectively what amount to lookups on one source of data, right? So we're creating a materialized view in our sales ops catalog. The key column of our view will be the order ID. So we're going to look up on this materialized view by order ID, and we are going to return some values from that materialized view that amount to the employee that processed that order, right? So that's coming from the sales info raw data. If I go into the sales info JSON, this is JSON, we will go to the basically the information that I'm going to return from this view. The store, the employee, first name, last name, location. So we create this materialized view so that we can join this to our orders table. Right? And that's effectively what we do here in step 3. So Roy showed you earlier a copy from job. Copy from jobs are used to ingest data. This is an insert into job. This is a job that's going to write data into the table that we just created. And the transformation is written using SQL, right? So this is how we're going to model our source data into our data product, data app, output table, whatever you might want to call it. It's a select statement. Should look fairly familiar to those of you comfortable with SQL. We are selecting from the table that Roy staged for us, this orders raw data table, and we are joining that to the materialized view that we just created on our order ID field. Right. So that's honestly most of the work in this transformation are these lines here, just joining between key columns of our source table and our materialized view. We are filtering our transformation because we only care about orders that were placed in a store, and a filtered transformation in Upsolver is just a where clause. And this commit time here, don't worry too much about this, but because this is a streaming use case, this tells the job how much data to process. And we're basically saying, process all of the data that was committed to our staging table between when this job started and when it finished, right? And then in the select statement, we output our fields. So this is really the extent of our transformation job. We can preview the job. So I've already actually built this, but as we iteratively develop and build out these jobs, we can preview what the job will do to our table before we actually run anything.
Okay.
I found really helpful as I iteratively develop things.
Yeah, that's good because That's, you don't want to like see the result before
exactly.
or after.
So we previewed 164 rows. It's not our entire data set, but it's enough of it that I can verify that this is doing what I expect it to do. We've got our order ID, our totals, our employee ID, and the name field. So this all looks good to me. So I'd go ahead, run my job. And now I have that end-to-end pipeline running, right? Roy's part of it is ingesting data from the source, staging it in staging tables. And then this insert into job is processing the data and loading it into our transform data table. We can, of course, query the output using that Athena integration. So now we'll select from that transform table. And we've already previewed this, so we expected that it would look as we wanted to, but now we have full verification that our data app or data product or target table, whatever we might want to call it, is doing what it's supposed to be doing. Now, in the real world, I would probably now hand this table or this query off to like QuickSight or some downstream process to create dashboards or reports on this refined data set that we've created with Upsolver. So that's kind of the first part of this pipeline, right? We ran really, at the end of the day, we ran one create table statement, one statement to create a view, and one transformation job. So 3 SQL statements. And now we have that pipeline running continuously. This is happening in a streaming fashion. So if we go back and look at jobs like Roy showed you, he was showing you the data load jobs. This is the job that we created, right? The one that's performing the transformation is joining 2 data sources and it's loading it into our target table. And just like Roy did, we can verify it's processed 17,000 events, 5 events per second. There's no delay. And we can see the charts and graphs that show us the processing behavior of this job that we've built. But the second thing I want to show, this actually goes back to a few of the use cases that we discussed earlier. And that's, what if now we need to change something? Right? We've got this pipeline, it's up and running. Let's say it's been running for a few days or a few weeks, and we assume that things are going well, but maybe we hear otherwise from one of our business users. All right. And I put a comment here into this worksheet. The business noticed that some orders aren't showing right. This often happens. Rarely do you get a pipeline right the first time, right? Or, as we discussed earlier, maybe our schema has evolved, or our source data has had a bug in it. The API that we're reading data from, has a bug. And so we're noticing some orders showing up as $0. So the first thing that I might do, I might work with Roy to do this, but let's first start by, let's look at that data app or the data product, the target table that we've been writing data into, and just try to verify that this is the case, right? This isn't a QuickSight bug or a graphing bug. Let's make sure the problem is in the data. And sure enough, it is, right? We've got a net total column here that's showing 0 for some of our orders. Right. So now let's try to work backwards. Is this issue with our raw data, right? Because we have access to the staging data in Roy's catalog, I can simply run a query against that because I want to know, is this problem in my transformation logic or is this problem in the source data, right? That's going to kind of help me understand what to do next. And sure enough, the problem's in the source data. Right? If I look at the raw data, we've got net total showing as 0. Right? So we've now confirmed the problems in the source data. Now, knowing that, I want to stop this transformation right away. Right? Andreas, this goes to your question earlier of how might you stop a job? Well, we stop a job by basically just telling it to end. Right? So I'm going to run this alter to command that's going to stop the job running. Right. So we've now stopped that job. It's no longer processing any new data into my target table. So now that that's stopped, let's do a little bit more of an inspection. And I'm just going to go into the raw data table. This is where it becomes especially useful to have all this metadata associated with all tables.
I just want to, Jason, I want to just stop you there for a sec. I really like this to see, or let me rephrase this. I love to see how the collaboration works here, because Roy, when he did the typical engineering work, right, he integrated the source, put the data in there. He didn't know that there was zeros in that column, and he didn't care.
Why would he? I mean, yeah,
because he's not creating the analytics with it. But in the end, it's like you now on the other end, maybe as an analyst, you figure out, oh man, now this is zero. How do I contact here? And if you would not know that it's Roy, you could look it up. It's Roy. Let's get in touch with Roy as well, and like try to figure something out, right?
Yeah, and here's kind of a use case, and I like this because I've often heard all elements in IT, they refer to things as like the blame game, right? There's a problem. Some analyst has detected that there's a problem in the data. And so a bad data analyst, and I use this term lightly, might start finger pointing and say, well, that's bad data. Nothing I can do about that. Go to the application team and tell them to figure out how to fix it, right? Maybe Salesforce is spitting out some bad data but me as a problem solver, let's figure out if we can fix this now, right? Because this is a problem that's affecting our business. I can go to Salesforce and say, go fix this, but that could take a month, right? So what I would do is I'm going to go into my raw data table here, and I'm going to click on net total. And again, we've now verified, first of all, if I look at value distribution here, 0 is showing up as the top value in my raw data table in over 5% of the events. So this is not an isolated problem, right? We've got a pretty significant scope of this problem. But let me also see if there's any other data that might help me understand this. And specifically, this is e-commerce data. So it's an order. An order is made up of items. Items have dollar values associated with them too, specifically unit prices. So the data person in me starts thinking, well, if my order total was wrong, can I calculate a new order total based off of the total of the items that are in the order, right? Maybe I can solve this through a transformation without waiting for the Salesforce team or whatever the e-commerce application is to fix the problem.
Yeah, makes sense.
So again, we've already stopped the job to make sure that it's not processing. And now let's go ahead and just create a new job, right? So we're going to create a new job. Now this start from, I didn't mention this earlier, but this now goes to the questions that were asked earlier about how do I replay or how do I backfill or how do I fix this pipeline that's caused some bad data to show up. With an Upsolver job, it's just backdate this, right? Now, in many cases, you would just say start from beginning, right? Go back to the source, the beginning of when we started loading data, or you'd say now, just start processing this from this point forward. In this case, though, let's go back to when this problem started, or let's go. So we just put a timestamp on here. We backdated this just a few hours in this example. Yeah. But because our table that we're writing our data into has a primary key on it, I mentioned I was going to revisit the primary key field. This table here has a primary key on it. So when this transformation runs and inserts into this table, if it finds a match on the primary key, it's going to overwrite the values for that primary key reference, to do kind of like an upsert use case, as is traditionally called in a data lake, right? So if it's a new order, it'll write it new. If it's an existing order, it will overwrite the row based on the new transformation logic that we've applied. So somebody had asked earlier, what if a new field shows up 2 months ago? Well, it's just a matter of do your start from 2 months ago and make sure that new field is included in your transformation, right? And we'll go ahead and backdate. I don't even want to call it backdate because that implies that you're actually going back in time. You're not really, you're just replaying historical data and adding that field in, or in this case, correcting the data that was bad. And just so you kind of see this logic, let me go ahead and create the new job here. We're reading from the same sources, but this let command, this is actually how you create calculated columns in an Upsolver transformation. So we're defining a new net total, and then we just have some array math that we're doing here. Don't worry too much about the calculation. We're summing the items array. So we're multiplying unit price by quantity, by discount. We're creating a new total. Now, in a real example, what I would do is I would add that, I would basically take that new net total that we fixed and simply write that into the same net total field. We talked earlier about how, you know, a modeled schema on the target side or on the data product side shouldn't change. In this example, I'm writing it to a new field just because I want you to be able to see the old and the new. But what I would do is I would just do this as net total. That way our end report doesn't need to change at all. It will just start populating with this fixed data that I've pulled through the transformation. But as I did with my initial job, I can preview it, you know, kind of make sure that that data looks as I expect it to. So this is why I actually have them as two fields. So I could see the existing net total and the fixed net total. Yeah. In cases where it's not zero, I just want to make sure it's the same. In cases where it is zero, I actually didn't get any of these in the sample. So I don't know yet if that's actually fixed. But again, I can go ahead and query my output table and figure out, do I have, so yeah, here's some net total was zero, and we've got our new fixed net total as a calculation on the transformation that I've applied. So that's how I can go ahead and kind of modify, you know, we talked about modifying of pipelines, whether that's to add functionality or add new calculations, add new enrichments, fix bad data, replay, you know, those types of things. Modifications in Upsolver are as simple as stop the first job and then create a new job that replays data going as far back as you need to. And because we as an Upsolver are orchestrating all this for you, you didn't have to worry about that kind of batch-oriented process of which jobs do I stop and in which order do I stop them, and do I have to delete files because I'm going to overwrite them. We kind of handle all of that logic for you in the orchestration of these pipelines. Now, the last step that I was going to show, I won't really spend a ton of time other than just show you, somebody had asked a question earlier about aggregations in your pipelines. And so a final result of this pipeline that we're building out may be that, right? We've got our orders data joined with our sales data, so we know which employees were working on which orders. Now we might want to create aggregations so that we can see which employees are servicing the most orders or are working on the highest number of revenue. Aggregations in Upsolver are as simple as group bys, right? So it's another create job. It's inserting into our sales by employee table. And all we're really doing, we're grouping by the employee. And then we're doing a count of orders and a sum of the new column that has the right total in it. And as this aggregation processes, we'll have this continuous automatically updating aggregate in our output table that shows, you know, aggregated results by employee. I'll need to let this run for another minute or so. But after this does, we'll have results in our aggregated table that shows sales performance by employee.
I like how clean this is. You know, it's like, it's very obvious how to create the jobs and do the stuff. That's
it's really nice to build, and that all of your building is through SQL, right? So we mentioned earlier, the entire pipeline process is done using SQL. But then to your point about readability too, right? Let's assume this has all been running, right? And now somebody's asking questions, or maybe a new employee has picked up for me, a different analyst is getting questions about the sales by employee table. You know, how is that aggregating? Why is it aggregating that way? In the catalog where you look at sales by employee, you see the job that's writing to it. So you click on it, you expand it, and you can see the exact SQL that is being used to populate that table. Yeah. And most data professionals are going to be fairly familiar reading SQL and kind of understanding what's happening. So without having to reverse engineer any Python code or Spark code or, you know, any language that may not be as familiar to me, I can read this SQL and I can see, you know, this job, when it started running from, it's outputting once per minute. So we have near real-time freshness. And here is the SQL that's creating the aggregated output that's stored into that table.
Yeah. And you don't have to care if this is batch or if this comes from a streaming source, right? It's because you never see this in these jobs.
Yeah, I mean, the extent that you would need to care about it is kind of taken by Roy's job, right? And really the difference is when Roy set up his ingestion pipeline, he created 2 ingestion jobs from S3, but let's say the sales data came off of a Kafka topic, just the way that the application was architected, it would just be copy from Kafka, right? And instead of bucket, it would say topic, right?
Yeah.
That's really the extent of the difference if it's, more batch oriented in S3 versus streaming data on Kafka. Once I get to my role as a data consumer, it doesn't matter anymore. It's a table, right? It's a table that I read from, a table that I write to, and I can query those tables using SQL.
I like that.
So the one other thing I wanted to call out is that if you look at the way that we designed this particular workshop, there is kind of like a producer and a producer AWS account with their own catalog, and as a consumer in the consumer catalog. Typically, to do that in like Spark, for example, or other engines, you have to launch compute in 2 different accounts, right? You have to go to the catalog in those 2 different accounts, right? You kind of have to operate in these 2 different worlds. So the producer in account A and the producer in account A and the consumer in account B, they don't really talk to each other. They kind of live in their own little bubbles. In Upsolver, it's one platform, right? Both Jason and I were working in the same platform. I was writing into account A with my catalog, and he was writing and reading from account B with his catalog. But in our navigation tree, it just looked like 2 entries, 2 catalogs. We both had visibility into it. We both can read and write from it. There's security stuff that you can set around it, but for this example, we just kind of did it that way. But it's one platform that kind of cuts across and abstracts away, regardless of what AWS account you're working on. And it looks like it's one platform, and it makes it super easy. So like if I want to produce data and I want to take a slice of that data, I want to give it to Jason into his account, I can just do that in my copy from job, and that's it. I don't have to really do anything else. So it becomes very, very simple to share data between accounts and for users to work together. Even though they work inside of their account, the data is inside of their account, they're using one platform that kind of cuts across. So it makes it super simple for consumers and producers to work together. And I can go look at Jason's job and make sure he's doing the right things. Make sure, right, if I have to double check his work and make sure that he's doing the right thing, it's right there in front of me. I can see what he's doing, how he's doing it. If I think there's a problem or he should do something different or better, I can let him know, and he can go update his job that way.
There was also a question about the jobs and the code. Is there a way of synchronizing this with Git, or is that planned?
Yeah, so that was a good question. Right now, we don't have Git integration built into SQL Lake. So like from the console, from the UI, you cannot Git check or blame or pull requests or those kind of things. But because it's all in SQL, we do actually offer a CLI. So what we've seen users do is actually write their code in like VS Code or in their own IDE, and then using Git and as their own mechanism, right? So like if I write SQL on my machine, Git push or commit it, and then you can do it that way. So the kind of the version control interaction is going to be outside of the SQL Lake interface, but we are working in a near-term roadmap to add that into the product so it becomes much more integrated.
This idea of a worksheet too, Roy and I were both working in worksheets, which can be easily downloaded and then added to whatever repositories you might be using. So if you kind of follow that process, that's something you can definitely do.
Yeah. Is the result table done, Jason?
Oh, I haven't checked. I would assume it would be.
I'm sharing the screen again because I'm interested in how this now looks.
Yeah. So the result table. Let me zoom in again here. There's a couple ways. So there's actually a question somebody had asked about how do you ensure the transaction completion apart from Athena queries? So it's kind of along your line. How do I know that things are done? And there's a variety of ways. Just visually, in the UI, if you notice my sales by employee table, it now has all these fields associated with it. So I know that we've got data in this table because we've automatically identified the schema that data has loaded into. I can also, of course, write an Athena query here against my final table and see the results. So sure enough, I've got employee IDs, I've got names, number of orders, total revenue. And then again, we've got system columns here that you can use to verify, when did that event come from and when was it processed. So we can kind of verify the results by querying the outputs. There are also, Roy was mentioning earlier, if we look at the job, so I can go to aggregate sales by employee job and see how data is being processed. So we've processed 222 events. There's no delay. If I scroll down, how many events were processed, any errors. And then we have these system tables that Roy alluded to. So right from the job page, if you want to dig deeper into job execution, you can just launch this worksheet here, which now will query the system tables. So you can see exactly what your job is doing, how many rows it's written, how much data it's processed. So if you really want to geek out on kind of what's happening under the covers, you can go into the system tables and see exactly what's happening, what tasks, what processes, and how much data is being written out to the target.
Or yeah, I understand that. Or you could also go you could go into the table, and then where you showed the percentages of the distribution, we should now also see for that column.
Oh, absolutely. Yeah, if I click on the table, so just like Roy showed for the staging table, you can see events over time. We can see for each of the field statistics. So these are the fields that were created by my transformation. I can see how dense it is. I can see top values. So if I just simply want to see, what data has been written into each of these columns, now I've got that as well. We've written in 222 values, and here's the distribution of data being written into that table.
Yeah. And where did we put the the aggregated?
The aggregated fields here, the number of orders and the total revenue. These are the
revenue
fields that we created.
Because was it here where we saw 0?
No, so that was the intermediate table. So this is kind of an important workflow, right? Of where to create the sales by employee, we first had to join our two data sources together in an intermediate step, which was this joined table. This is where we saw net totals of 0 that were incorrect. So if I look at the net total here being 0, now remember, in the real world, I would not have this as 2 columns. I would probably just have it as 1 column that we fixed. But if I go to the fixed column here, you can see no longer do any zeros show up in the distribution. So if you just want a visual that the new column is being processed appropriately. And, we can see the new column is showing up in 58% of our events. This is still playing catch up a little bit. So this has been running for, I don't know, maybe 3 to 5 minutes, give or take. So it's going back through, days worth of data to reprocess the old data. And looks like we're about 60% of the way there.
Cool. I have one more question. Because there were already questions in here like, how is this processing in the background? Is this using this tool or that tool? I don't want to go into that detail because I'm guessing also, Roy, you answered here by Jason that there's a lot of custom stuff from Upsolver.
Yeah.
But this setup we saw when you showed it, Roy, we saw like cluster performance or something. How is this all set up? Like, because first of all, you need to define how much you pay and also how much performance you're getting from Upsolver, right?
So you can. We didn't show this in part of the demo, but basically you create clusters inside of Upsolver, so you can define a cluster, and then your jobs either operate on that particular cluster. If you have multiple clusters, you can create a job and associate it with a cluster, right? So like my ingest jobs can be associated with the ingest cluster, and then Jason's job can be associated with his clusters, right? So we're not necessarily sharing resources if we didn't want to, but that's something that we can do, or we can all share the same clusters. But yeah, when you create a cluster, you can pick which instance types you want on it. We do use spot instances by default. So we're going to try to get the best spot price possible for your instances. We do auto scale up and down based on the utilization and based on the volume of data and the kind of transformation that you're doing. So for the most part, you don't see users really mess around with cluster configuration. It's kind of like you know, a data admin or data administrator or engineer create the cluster, defines it once, and then that's it. Then we kind of scale it up and down.
Yeah. So how does that work? Do you then select that you say, okay, I want these instance types and that amount of instance types and scale this up and down by that amount of percent, and that's it?
Yep.
Okay, that's nice. Okay.
Yep. Pretty simple. And then the pricing on Upsolver, like we charge based on data ingested. And the compute cost is AWS cost. So if you have, you know, like EC2 discounts through your EDP and AWS, you obviously get that. Upsolver just charges you based on the data ingested. So once you ingest the data once into the product, you pay that. And then anything else that you do with it, you don't pay anymore. So like in the example that we showed you, there were 2 jobs that were ingesting that I created. You pay for that amount of data scanned into the data lake, but then the jobs that Jason created, he read from those tables multiple times, aggregated in different ways. He replayed the data multiple times. He didn't pay for any of that, right? Like you didn't pay to Upsolver for that. So if you had to replay the data, to go back and replay 6 months of data, you're not paying to rescan the data because we already ingested it once.
Yeah.
Right.
So you're basically only paying for the cluster resources that you have running.
At that point, yeah, exactly. Cool. So
Because
it's compared to other platforms like we talked about before, where you throw more hardware at it and you end up paying a lot more, both to EC2 and to Snowflake, or EC2 and to Databricks.
Yeah.
With Upsolver, like if you scale up and down, it's just an EC2 cost. Yeah. And if we're using Spot anyway, you get much better prices anyway.
I should mention too, if anybody's following along with the workshop, or if anybody is going back now and wanting to try this for themselves, we do have a hosted sandbox environment as well that runs in our cloud. So you don't need to spin up your own EC2 machines or your own clusters to try Upsolver. If anybody wants to try it, you can just go to sqllake.upsolver.com, create an account. We don't ask for a credit card or anything like that. You can basically get onto our sandbox environment at no cost and try. Try that.
Yeah, I'm actually sharing a slide.
Yeah, I just wanted to say, can you share something where people should go? Oh no, that's the wrong thing. That's right.
Yeah, you got it.
Sorry.
I mean, it's a big thank you, first of all. I think to you, Andres, and to everybody who joined. It's been a really, really cool experience. I'm glad we had an opportunity to do it. You can join our Slack community channel. So if you have any questions to me or to Jason or to anybody else want to follow up, let us know. We're all there. Feel free to join and ask questions. And then, like Jason said, sqllake.upsolver.com will bring you to the sign up page. Just, sign up with your email, and then you can go use it. So everything that we showed you today, you can do on your own. You can connect to your own data. So if you have a Kafka cluster on MSK or Confluent or S3, you put your credentials in, and then we can read directly from those, and you can write back into your own catalog, your own S3 bucket, your own Snowflake if you wanted to, and just the sandbox does the transformations and the compute piece of it, and it's all free. So
yeah. Is there a time limit, or is there a how's it called? Like you have a few $100 free. How's the?
No, I mean we say 30-day trial, but honestly, you can just keep going. The only thing is the clusters hibernate after a little while. So if you create a job and you leave it alone and you walk away and you don't come back to it, we automatically hibernate the cluster. But the second you log back in, it takes like a minute or two, and then the cluster comes back up, and then your job starts playing again.
Cool.
Yep. But you can feel free to play with it as much as you need.
Yeah. I play with it. I'm most likely also going to play with it.
Play, build, experiment, do whatever you want to do.
Yeah, and let Roy and Jason know your experience. I'm guessing who Roy, should people contact you or Jason?
If feel free to contact me, roy@upsolver.com, or just jump into the Slack channel. Yeah. You can find both Jason and I there.
Yeah, okay. I'm guessing some people are going to like this and try this out and have questions.
Yeah, absolutely.
All right. I think let's end this here. It feels like a high note.
Yeah. Andrew, thank you so much. I really appreciate it. This has been it's been pretty awesome. Hopefully we'll do it again soon. I hope everybody on the stream enjoyed it.
I've been looking at how many people are here. It looks like people enjoyed it a lot.
Good.
So thanks everybody. Thanks Roy. Thanks Jason. See you next time. Next stream for me is Wednesday. So awesome. Roy and Jason, please stay here for a sec. I want to chat with you.
We'll do. Thank you.
And then, bye everybody.